This video deals with finding the solutions to trigonometric equations. Alright, let's start with something like cot x is 1 over the square root of 3. Okay, we want to solve it on the interval 0 to 2 pi, the closed interval 0 to 2 pi. Well, cotangent x or cot x is simply 1 over tangent x or 1 over tan x. So 1 over tan x is equal to 1 over the square root of 3. And what we can do is take the reciprocal of both sides, so in the end we're trying to solve the equation tan x equals the square root of 3. Now tan is positive in the first and third quadrants, so let me just remind you of that. Here we go. Okay, so what we have is theta, we have pi minus theta, whoops, and pi plus theta, let's put theta there, and 2 pi minus theta. Now, all the trigonometric functions are positive in the first quadrant, that's sine, cos, and tan. In the second quadrant, we have only sine is positive. In the third quadrant, tan is positive. In the fourth quadrant, only cos is positive. All right? All stations to central, one way to remember it. Okay, so we have tan x equals plus square root 3. Now tan is positive in the first, where all of them are positive, and in the third quadrant. Okay, so in the first quadrant, theta is inverse tan square root of 3, which is pi on 3. I remember the exact ratio with the triangle there we've seen in previous videos. In the third quadrant, the solution theta is pi plus theta, which is pi on 3. So pi plus pi on 3, which is 4 pi on 3. So the solution set for cotangent of x equals 1 on the square root of 3, which is the same equation as tan x equals the square root of 3. The solution is pi on 3, 4 pi on 3, in the interval 0 to 2 pi. Okay, let's have a look at another example. Alright, now let's solve cos 2x equals 2 minus 3 sine x, again over the same interval 0 to 2 pi, the same closed interval. Okay, now from some trigonometric identities we know that cos 2x is 1 minus 2 sine squared x. Okay, so let's substitute that in there on the left, and that's equal to 2 minus 3 sine x, the original question. Okay, so let's take some things onto one side. We can take the 2 sine x squared over the other side. We can take 2 minus 1 if we take the 1 over this side, and what we're left with is 2 sine squared x minus 3 sine x. Remember, we took the minus 2 sine squared x over to the right hand side here, so we have plus 2 sine squared x minus 3 sine x, and then we have a 2 there, but we're taking the 1 over the other side, so 2 minus 1 is 1, and all that's equal to 0. So 2 sine squared x minus 3 sine x plus 1 is 0. Okay, we can factorize that. Sine x is the variable. And when we do that, factor it on the cross if you wish. We have 2 sine x minus 1 in parentheses times sine x minus 1, and that's all equal to 0. So null factor law says that 2 sine x minus 1 is 0, or sine x minus 1 is 0, or both. Okay, so let's transpose this. 2 sine x minus 1 is 0, so take the 1 over the other side, divide by 2, sine x is a half. Okay, and the other one over here, sine x equals 1. Okay, now sine is positive in the first and second quadrants. Moving from our circle above, first and second quadrant. So in the first quadrant, x equals inverse sine a half. Well, that gives us pi on 6 from our exact ratios. In the second quadrant, x is pi minus theta, pi on 6, so pi minus pi, which is 5 pi on 6. All right, and so we have 2 solutions there already. Okay, it's from one of the factors. Now from the other factor, and for sine x equals 1, we know that x is inverse sine of 1 is pi on 2 in that interval. And there's no other value in that interval. So our complete solution set contains 3 solutions, pi on 6, pi on 2, 5 pi on 6. And that is it. Remember, with the sine function, the range or codomain is from -1 to 1, and so inverse sine of 1 is pi on 2. That's the first, if we were to plot the graph like this, you know, we've got like this, there's 2 pi, this one is pi, and just here, that 1 is pi on 2. Okay, and that's the only, in the 0 to 2 pi range, that's the only value we get, this one here. Okay, pi on 2. So our solution is pi on 6, pi on 2, and 5 pi on 6. Okay, that's it.